Hi guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. In my channel, I deal with different aspects of mathematics, physics, chemistry and biology and other related topics and application areas. So in this case, we are going to look at a concept in a vector calculus, and this basically is going to be the concept of a vector differential operator. And this is going to be a very particularly relevant topic for us in trying to calculate some of the aspects like rotational properties of vector fields that we're going to encounter in some of our discussions. So in this particular case as well, we're going to describe the concept of a maximum rate of change, especially in fluid dynamics. And also we're going to see that in some areas that we're going to look at, especially in trying to describe the concept of what we refer to as electromagnetic theory, especially on the concept of volume integrals. It's going to be very applicable for us in understanding this specific concept. So therefore the concept of the vector differential operator is going to find this several applications. And as we had said in our first video on the concept of differentiation, we had given this specific symbol which is delta to imply a particular change. And therefore, in our specific discussion for today, we're going to have a different notation, which is going to be an inverted small triangle. Therefore, this is going to be referred to as del, and this specific symbol for del, therefore, is going to represent our vector differential operator in our proceeding discussion. So therefore, that is what I'm going to be given as a notation for this specific heading for our discussion today. And we're going to define this differential operator del by being given as the vector differential operator del is going to be defined using this specific equation, whereby we're going to have d dx of I plus d over dy of j plus d over dy z, where we defined different elements of vectors, especially in three-dimensional rectangular coordinate systems. So I presume that we understand the concept of I, j, and k. So therefore, this is going to be the denotation that we are going to use in this particular case, implying to the concept of this del. So in this specific cases, we're going to see that for especially a unity vector, we can be able to give another version of this specific del by writing I d over dx plus d over dy j plus d over dz k, and these are vectors subset. So this one is going to be preceded by this, so we're going to have k and then j given as such. So this is k d over dz, which is also a vector. So you can be able to denote this specific del using either of the two, but preferably depending on what we are going to discuss, and therefore I'm going to elaborate on what basically we found. So this is going to be a vector quantity, and therefore we're going to see in how it's going to be treated in various areas of its application, especially in the preceding discussion that we're going to have. Now the vector operator is going to possess just similar attributes to the vectors that we have discussed, especially in our previous discussion, whereby we say that vectors possess the concept of magnitude and direction. So therefore, this is going to be displayed by this vector operator that we have indicated, which is known as the del. So we're going to find wide applications of this differential operator, especially as I said in trying to describe what we call gradient, divergency, and what we refer to as curls, which of course are going to assist us to describe what I referred to as these various areas of application, especially in the electromagnetic theory, trying to describe the rotational properties of vector fields. And in some areas, as I said, this is going to assist us to describe the rates of change, especially over various functions that we're going to see, or other unique functions that we're going to see, of course, which are, of course, the descriptions of various vector fields, as I've said. So in this case, this is the specific designation that we're going to use for applying del. And there are some other areas that we're going to see this specific del being used in combination with other symbols to imply a specific, of course, derivatives like the gradient, divergence, and curves, as I've said. So in our next discussion, we're going to exclusively look at these specific three applications of the vector differential operator and try to define what the gradient, divergence, and curves are, and how we can be able to represent them in form of an equation. So catch us in our next video, and kindly check on our comment description boxes for various videos where I'm going to put a link of similar discussions or the similar topics, so that they can assist us, of course, understand wider from various perspectives. So that is it for now, guys. Bye. God bless you.